So give us a couple of minutes and then we should theoretically be working. Yeah, famous last words. So give us a couple of minutes and then we should theoretically be working. Yeah, famous last words. Wow. Okay.
Serious echo. Okay.
Dude, that was one heck of an awesome echo there, wasn't it? Okay, so I think we are live now. So welcome to everybody to today's Delta Lake Community Office Hours. I am just currently trying to set up everything on YouTube and as well as on LinkedIn. So give me a minute to try to get that in order and then we will rock it. And so perfect. We are on LinkedIn, I believe now. So excellent. So thank you very much, everybody, for joining today's community office hours. Right now, we've got Christian from Scribd, we got Scott from Databricks, myself from Databricks, and I think we're going to have TD joining us a little bit late, but we are live on LinkedIn, YouTube. So if you have any questions when it comes to Delta Lake, you are currently in the right set of office hours. We're going to run for about 20 minutes today. So we're going to end at about 9:20 a.m. Pacific time, or if you have no questions, then we'll end actually a little bit earlier. But I did want to let Christian and Scott introduce themselves real quick for starting off. Christian, why don't you start? Provide a little background on who you are and you as a Delta Lake committer, what projects you currently are focused on.
Sure. Yeah, so I'm involved in Delta insofar as I'm a committer on Delta RS, which is the Rust implementation of the Delta Lake protocol, and Kafka Delta Streams, which is a Rust daemon that streams JSON messages from Kafka topics to Delta Lake tables, which Scribd is using in production right now for about 60-ish topics.
Thanks very much, Christian. And it was actually completely by accident, but I just realized I was wearing my Scribd vest today as well. So,
Oh, yeah, sure. Yeah. I believe that was an accident.
It was. It truly was, actually. But yeah, it's a great shout out, though, actually. Yes. Yeah. All right. Perfect. Scott, why don't you introduce yourself real quick?
Thanks, Denny. Good morning, everyone. Hi, I'm Scott. I'm a software engineer on the Delta Lake ecosystem team here at Databricks. Recently, I've been working on a variety of open source projects that we contribute to, such as the Delta Standalone library, which is the main low-level library for new connectors to connect to the Delta Lake protocol. Also, last week, I open sourced the latest version of Delta Lake 1.1, which is really exciting. And now I'm continuing to work on some open source features and performance improvements.
Perfect. Thank you very much, Scott. And hi, everybody. My name is Dang Lee. I'm a developer advocate here at Databricks. Longtime Spark guy, longtime Delta Lake guy. So hopefully I'll also be able to answer your questions here. I did want to start off. I believe it's more on the boring, not boring, the more uber detailed part of it, which is, Christian, you had in yesterday's Delta Rust API meeting, we had talked about basically trying to figure out how to read the metadata faster. I was wondering if you had any concerns or questions that, in fact, you could probably potentially ask Scott right here concerning the metadata itself, actually.
Yeah, actually, rather than faster, it's more the concern I have more is around memory. So currently, when we load the transaction log for a table in Delta RS, we're using a row-based format. We aren't using arrow or any kind of a columnar structure. And Denny, I think, had mentioned that you guys were facing some memory issues in the Delta standalone reader. And I guess you may have already started to take steps to resolve it. And so I'm just interested to hear any gotchas you hit along the way, or just anything about the problem as you're facing it in the Delta standalone reader.
Mm-hmm. Yeah, that's a really interesting problem, and I think I should have a decent enough answer for you. So yeah, so the main issue is
why I implied that you had the answer. So yesterday.
The main issue here is that you need to get the correct and latest snapshot of a table, which requires reading all of the actions. You need to know what are the add files that were added to the table. And you also need to know what are the remove files that were removed, because sometimes those will cancel out. That's why you have to read all of them to get to the latest point. So typically you do that all at once, you load it all into memory. That's where the memory concerns come from. A better way to do it is with an iterator method. But you can't just iterate forwards in time through the transaction log because there could be some remove files that come on later. So the trick that we did, and the code is open source, feel free to look at it. In fact, you can email me and I can send you the exact links. But you actually iterate through the transaction log backwards. And as you're iterating backwards, you keep track of the remove files you've seen and the add files you've seen, and you use that to actually decide which files to return to the reader. So that's when you're updating and actually reading all the files. And just a quick hint, when you instantiate a new Delta log, as I'm sure you probably do in your REST API, you need like two things that a Delta log requires to be instantiated. It is the correct protocol and the correct metadata of the table as well. And you can do that too using Iterator API. You just read backwards until you find those two, and then you're done. You don't need to load all the actions into memory. Let me know if that made enough sense for you.
Yeah, it does. I appreciate the answer, and I'll check out the source.
Sweet.
Perfect. All right. So that was committer to committer question. So that's pretty sweet. All right. Without further ado, TD, why don't you do a quick introduction yourself? We already did ourselves. We have TD now joining us, which is awesome because it's good timing because we have a bunch of questions from LinkedIn that we got to go answer. We're going to throw them all your way, TD. I'm joking, but still introduce yourself.
All right. First of all, apologies, everyone. I was a little late. My previous meeting ran over. My name is, well, TD. Everyone calls me TD. I am a staff software engineer in this company and the same team as Scott. We work together very closely. And I've been working on the Delta Lake project for the last 4 years since its inception. So having way too much fun working on this Delta Lake stuff that I'm still not bored of 4 years. So, yep, ready to answer all your questions. So throw all the hard balls at me.
No problem. Well, I mean, in fact, actually, so Shiv from LinkedIn has a bunch of questions. So I'm going to go backwards first, just because and then of course Christian and Scott definitely chime in too, right? But I'm just going to direct some of these because they seem to be very much in DD's wheelhouse. So let's start with the most recent one. So Shiv, please continue asking your questions. This is awesome. Can I run parallel queries to Delta Lake if I need to run thousands of queries? And so, yeah, why don't you talk a little bit about the fact that, yes, you can definitely run parallel queries to Delta Lake and the context behind it.
Yes, you definitely can. And you can. The coolest thing is that you can run these parallel queries within the same cluster or across any number of clusters with the full consistency guarantee, because Delta internally maintains the version snapshots of the table. So each of these queries will see a consistent version of the table. May not see the same version of the table because the table can keep getting new versions as people are writing into it as well. But every read query will see a consistent version of the table, of the entire table, rather than, oh, it sees somebody's writing into it, it sees half of that right, but not the other half. That won't happen. Either it will see entirely version 1 or version 2, but nothing in between. So yes, you can run things in parallelly, things will be consistent. And whether you can actually run it is your cluster configuration, whether it has enough capacity in your cluster for Spark to run those tasks and stuff. But from the data format point of view, you can absolutely run everything and you get full consistency guarantee.
Excellent. Thanks very much, TD. And I'm just going to go to the next question, though. Christian, Scott, if you have anything that you'd like to add, by all means. So the next question, now, Shiv, it's also from Shiv. Now, this is specifically the Z ordering and how and why. The question is, can you please explain how Z ordering works and why it improves performance? Now, before I go ahead and hand that off to the gentleman here, I did want to call out that Z ordering is currently specific to Databricks. The Delta version that's in Databricks, so as opposed to the one that's in OSS Delta. We definitely want to answer the question, but we wanted to call that out. Okay, so saying that, who would like to tackle the question concerning Z ordering?
I can, but I want to let others have an opportunity.
You go first, TD, and I'll add on anything if I.
Okay. So the simplest way to think about Z ordering is basically it's a very fancy form of multi-dimensional sorting. Well, technically clustering, but it's hard to explain this without the visuals and slides. But say if you have two columns and you want to cluster the data such that reading from both the columns is you can filter down which files to read by some sort of clustering on both those columns. Now, the naive way would be you have a primary sorting column, you sort by, and then within and then a secondary sorting column within that, and then split that data into files. The good thing is that if you really do the math, to overuse that word, is that if you have queries that filter by one of the columns, you can filter down very well. But if you filter by the other column, it doesn't filter down very well because one is a primary sorting, the other is a secondary sorting. What Z order, or the generic term is space filling curves, does is that it balances it out across the multiple columns. Like, for example, to put some sample numbers on it, like with simple primary secondary sorting, if you filter by column 1, it will filter down from 100 files to 2 files. But if you filter by column 2, it will filter down from 100 files to 50 files. Not much better. Whereas if you use these space filling curves, then both columns, it will filter down to, let's say, 10 files. So it's not the best for any individual column, but it's more evenly balanced between whichever column you want to filter by. So that's the idea about space filling curves. And Z order is just one particular type of space filling curves. There are other space filling curves like Hilbert curve and stuff. And so that's the basic idea of Z ordering, is how do you cluster the data across files such that when you want to search for a particular row with a particular value of those multiple columns, you can, without reading the data in every file, you can very easily quickly narrow down to, okay, these are the only files that can have those particular values, because these files, those two columns, the min max values of those columns in these files match has a small range that matches the thing, and other files don't have that, cannot have the possibly have that value. Hopefully that answers the question. It's hard to explain that without slides and the visuals, but hopefully that conveys the point.
I certainly think it does. By the same token, folks, if you do have more questions concerning Z order, by all means do ping us. I'm actually going to go ahead and when we answer the next question, I'm actually going to get the blog post that we wrote on Z ordering, and I'll paste that in both the YouTube links and the LinkedIn. So that way that provides the additional details. But I figured at least giving us a chance to answer first, that'd be really good. The next question, actually, I'll answer. At least I'll start, I should put it that way, and we'll go from there. So it's also from Shiv. It's a great question, which is, how can I replicate a Snowflake database as a Delta Lake? Okay, so in other words, you're going to go from, and I'm going to actually just answer the question, not so much targeting any particular database, just more the idea of a database to Delta Lake. Okay, so, and this is because that's a very common approach. And typically what's happening is that most database systems are very proprietary, so they have their own version of an unloading or a bulk export mechanism. So you're going to want to basically utilize their bulk export mechanism to get the data into blob storage, whether that's in CSV initially, or some of them actually have Parquet, some of them don't, so I don't want to automatically assume that. But the context is, since you're talking about databases, typically structured data to begin with, which means CSV or tab or that type of format is perfectly fine. When you export the data out, then having Delta Lake read it is pretty much a straightforward, literally just a straightforward, okay, in Spark read, bam, you create the Delta Lake and you're good to go. The one little I wouldn't say exception, but one little call out would be that if you can't export in Parquet, there's an in-place conversion of a Parquet table directly into Delta Lake as well. So you could always utilize that. Now, The real concern isn't so much that part of the replication, honestly, though, even though I've went on a little already. The real concern is more like when you're online and you're continuously processing data, how to get that data in. And typically that means you're going to have to do some form of streaming mechanism or an ETL, a regular periodic ETL process. And so you will always need to separate that bulk export portion from that regular ETL batch or stream process. Now, honestly, most of the customers that we work with when it comes, and I'm sorry, I shouldn't even say customers. Most of the community members we work with, whether it's a Databricks customer or a Delta Lake user, what they're typically doing is that they have that two separate process. One is that bulk export from a database, right? I've seen it happen multiple times, Oracle, SQL Server, whatever else. And then upstream, they work on basically a regular ETL process where they multicast the data out, one time to the database and then directly to Delta Lake. They do a reconciliation between what's in the Delta Lake versus what's in the database for over a period of time, let's just say 2 weeks or a month, to make sure the numbers are matching. And then once they validate that, then they can shut off the flow into the database and it goes directly in Delta Lake. So I provided a whole bunch of context and recognize the fact that if we want to dive deeper, we probably want to actually have a much longer conversation in the Delta Lake user Slack. So please go to delta.io. Near the bottom, there is a Slack channel link. You can just join us there. And my name's Denny. You can just hunt me down. Okay, so just want to call out, but hopefully that answers your question or at least provides enough context. Anybody else like to add anything on that I might have missed? I'm seeing nods, so I think I think that'll be good. Okay, perfect. All right, I'm going to go switch to the next question. It's from Sharon Jeevy. I apologize if I said your name incorrectly. This one I'm definitely going to target UT just because it is about merge. Okay, does merge? Yeah, exactly. Does merge a Spark SQL Databricks rewrite the files again, even if there are no inserts or updates when it comes to utilizing Delta Lake, the merge statement?
Okay, good question. So the way merge works is in two passes on the data. The first pass, it scans the data to identify which are the files that contain data that needs to be updated or deleted. And then in the second pass, it rewrites only those files. So in your table, if any file doesn't contain any data that needs to be updated or deleted, it will not rewrite at all. So merge is very selective in that way. Now, how many files out of your table will actually needs to be rewritten is a kind of a separate question, and it totally depends on the distribution of your data, the data layout, the changes that are trying to merge. What is the distribution of those changes? Is there in any spatial locality in them and not? Those are the stuff that makes a difference in the merge performance. And things like Z order and basically data clustering in the data layout can make a difference and make merge faster. Because it limits the changes, the number of files that needs to be rewritten to a smaller number of files by clustering the value, the key space into a smaller number of files. If you're touching only a smaller range in the key space, there is data locality. So hopefully that answers the question.
Actually, it does. So I think that's probably all the time we actually have today for today's community office hours. So apologies, but we had some great questions. So saying that, I did want to call out a couple of things. Number one, I'm going to share actually, it looks like I can't share my screen today. So my bad on that one. But I did want to call out there is a Data and AI Summit CFP call for presentation. So by all means, please go ahead and the deadline currently is January 7th, 2022. So please go ahead if you've got a great data session. It does not have to be about Delta Lake and Spark, by the way, just any session on data and AI. We'd love to have you go ahead and present there, or at least call for presentations to do it. if you're looking for this video, it's actually going to be both on LinkedIn, where it is right now, as well as on YouTube. So there is the YouTube channel, Delta Lake YouTube channel. So just go to delta.io. At the bottom, there's links to both the YouTube channel and also the Slack channel. So since we didn't answer all of the questions that did pop up, again, apologies for that. Please join us on the Delta user Slack. We are there and we will go ahead and answer your questions there as well. So saying that, I think that's it for today. I want any last words from Christian or TD or Scott? Okay, I'm getting nods, so I think that's good to go. So again,
just only one thing, keep these
perfect.
questions
Please
coming.
Yes.
These are absolutely great questions, and we want to educate the community on the internals of Delta Lake. So please keep asking these questions in all these different venues. You heard from Denny from all the different venues, Slack, etc. So please keep asking these questions. We're happy to explain and help and make everyone in the community aware of the Delta internals and how it helps in different scenarios.
And a special call out to Shiv from on LinkedIn. You're asking some awesome questions. So again, apologies for not being able to answer all of them. So please join us on the Delta user Slack. We'd love to answer them, and it'll allow us actually to be a little bit more long formed in our responses too, so that we get the details as well. Okay. So again, thank you very much, everybody. Really appreciate your time. And we'll probably see you. Yeah, we'll see you in 2 weeks. Yeah, we'll still have one more, and then we'll take the winter break for everybody. Okay. So again, thank you very much, everybody. Thank you, Christian, Scott, and TD for attending today's session and providing your answers. Thank you to everybody on LinkedIn and YouTube for going ahead and asking some amazing questions. All right, have a good one, everybody.
Thank you.
Awesome. Bye.